Okay, so this is Math 116, Section 1.6, and this is actually the section where Math 116 begins. So everything we've seen up through here has actually been stuff we've covered in Math 94, 95, or 98 if you took the quick version of it. 1.6 is going to be using those same linear equations we saw in 1.3, but this one's very, very much applications directed at business problems. So first I'm just going to go through some definitions here, and you're going to use these definitions throughout the rest of the book. And so this, I have a little, in the notes, I have a handout of this. It's a good thing to have open while you're working on this, and it'll make a good reference later in the course also when this comes back in Chapter 2. So in terms of definitions, we have profit P of X, revenue R of X, and cost C of X. And profit is going to be revenue minus cost. And we're going to see this relationship a lot. So revenue, remember, is how much money we took in. Cost is how much we spent to make the stuff. And so if we do how much we took in minus how much we spent, what's left would be profit. So if cost is bigger, profit is negative. We've lost money. If they're equal, that's going to be our break-even point, our equilibrium point. If we received as much money as we spent, then the profit is zero. So that's our break even. That's actually right down here, profit of zero, or R of X equals C of X. And so there's our profit. Marginal profit, marginal revenue, marginal cost. What that is going to be the slope of the profit function or revenue function, etc. So it represents the profit from selling one more unit. So when we change one unit in X, it's going to be that change in Y, or the slope, for either profit, revenue, or cost. Equilibrium point I covered. Market equilibrium is when the quantity of a commodity demanded is equal to the quantity supplied. We'll see that at the end of the section. Okay, so this first one is, suppose a ceiling fan manufacturer has a total cost function of this and a total revenue function of that. What is the equation of the profit function P of X for this commodity? So remember, on this sheet we have profit equals revenue minus cost, and we're given revenue and cost so we can get profit. So profit equals revenue minus cost. So P of X is going to equal our revenue function, 65X, minus the all-important parenthesis there, otherwise the fixed cost doesn't get subtracted. So 31X plus 2040. And then running that through and collecting terms, our profit function will be 65 minus 31 is 34X, and then it's going to be minus, make sure you get that sign distributed, $2,040. B is what's the profit on 40 units. So basically that's just saying find P of 40. So we just made a profit equation, and now we can toss a 40 in there and figure out what the profit would be if we sold 40 of these things. And this I just threw in a calculator, and I got P of 40 to be negative 680, which means we lost money. We didn't sell enough of these things to cover our expenses. So that's the next part. Interpret the result. The total costs are less. The total costs are less than the revenue. The total costs are more than the revenue. Total costs are the same. It's not the same. So in this case, the cost was more than the revenue because it came up negative. So it's that one right there. And C is how many fans must be sold to avoid losing money. So what that means is we can do R of X equals C of X, or we can think of it as P of X equals 0. They both get there. Since I have P of X, I'll just do that. 34X minus 240 equals 0. So when is the profit 0? Bring the 240 over. Sorry, 2040. And then divide over the 34. And I got X equals 60. So they have to make 60 units just to cover production, and then every unit after that they'll make money. Okay, so this next one, a linear cost function is C of X equals that. Assume C is measured in dollars. What are the slope and the C-intercept? So don't let the C-intercept mess you up. What that is C is the output, it's C of X. So this is just like the Y-intercept. So what's the slope? Remember, that's mx plus b, so slope is in front of x. So the slope is 12, and the c-intercept, which is like our y-intercept, is that 300. What is the marginal cost? MC. So MC stands for marginal cost. Marginal cost is the same thing as the slope. So it is 12. What does the marginal cost mean? Each additional unit produced costs this many dollars. So to make the next one of these little widgets, we'll have to spend $12 more. So it's this one right here. How are your answers in A and B related? So slope equals marginal cost and C equals fixed intercept. So that's what we're just looking at there. And we know marginal cost because that's the one that changes. So that's the marginal. And then the intercept doesn't change, so that's the fixed. So D, what is the cost of producing one more item if 50 are currently being produced? So with this, I could put in 50 and then put in 51 and then subtract those. And what I'd find is it comes out to 12. Because remember, 12 is that marginal cost, and the marginal cost is each additional unit produced this much in dollars to make. So for each additional unit, it's 12. So it doesn't matter if it's between 50 and 51 or 1,000 and 1,001 in this case. It would still be $12. Okay, so number 3 goes, company charting its profits. Notice the relationship between the number of units sold X and the profit P is linear. So if 190 units are sold results in this profit and 240 units sold results in that profit. Write a profit function for the company. So it looks like we have XP is going to be our ordered pair that we're working with. So for XP, and I like to write that down just so that I put things in the right spot. We're given these two ordered pair. 190 units, that's X, results in this profit. So 190 results in 35.20. And then 240 units results in that profit. And so given 2 points, I can find the slope, and with the slope and a point, then I can find the equation. So I'm going to go, our slope equals y2 minus y1 over x2 minus x1. And this is back in section 1.3 if you need to review it all. And then kind of grind this out with the calculator, and I got 2,900 over 50, and then reduce that further. 50 went in, so M was 58. And then what I can do is use that the point slope formula from 1.3. So in this case, it would be P minus P1 instead of Y minus Y1 equals MX minus X1. So our profit is going to equal, we can use either of these points. I use the smaller numbers just because it seems easier. So P minus P1, so that's 35.20 equals M, we just found that over here, 58, and X minus X1, which was the 190. And then just clean this up, and then that's our profit function. So P minus 35.20 equals 58X minus 11020. And then I'll add this over, and that got me to P, or P of X if I want to be fancy, is 58X minus 7,500. So that would be our profit function based on those two data points. And then B is find the marginal profit. Way easier. It's just the slope. It's the exact same thing we have here. So that would just be $58. So for every unit we sell, we get another $58. Okay. Number 4, manufacturer sells belts for $14 per unit. The fixed costs are $1,800 a month. Remember, that's things like rent, electricity that we have to pay whether we make anything or not. And the variable costs are $6 per unit. So it costs us $6 to make each of these belts. Write the equations for the revenue and the cost. Okay, so R of X, the revenue would be manufacturer sells them for $14 per unit, so $14 for each unit sold. And then the cost function, the variable cost was $6, so $6 times every unit made. And then the fixed cost, no matter what, we got to come up with $1,800. And so that would be our cost equation. And then find the break-even point. So that's the place where the revenue equals the cost. Remember, that's back here on the sheet. So R of X equals C of X. So 14X equals 6X plus 1800. And then I can scoot this over, and that gets me 8X equals 1800. And then divide over the 8. And I got 225 when I did that. Okay, number 5. A company distributes a college logo sweatshirt that sells for $50 each. The total cost function is linear. The total cost for 100 sweatshirts is that much, whereas 250 is that much. So that's going to be our ordered pairs. A is write an equation for the revenue. So revenue, remember, is how much we sell it for times the number of units. So they sell them for $50 each. So R of X is going to equal 50X. Cost function, that one's a little more involved. So total cost was linear, and we know 100 shirts goes with $43.60, and we know that 250 shirts goes with $70.60. And so now, given that, I can find the equation of the line. So our slope will be y2, y1, and then x2 minus x1. And then putting that in calculator, I got 2,700 up top, 150 below. So my M came out to 18. And so then that 18 is going to be my variable costs. So now I can choose the 18 in one of these points. And again, I'm doing the y2, y1, or sorry, the y minus y1 equals mx minus x1. So point slope form to get this into slope intercept. So y, I'll use the easier numbers or the smaller numbers for the point. So y minus 4360 equals m, which was 18. 8 minus 100. And then run that through. 1800x, or 18x, and 8 times the 100, so negative 1800. And then add this over. So then y equals 18x plus 2560. And that y is really my cost as a function of x. Find the break-even quantity. Okay, so that's where, again, R of X would equal cost. So we'll go 50x equals 18x plus 2560. Bring the 18 over and get 32x equals 2560, and divide the 32. So it looks like 80 sweatshirts is what they have to produce to break even. Okay, number 6 is if the demand for a pair of shoes is given by 2p plus 5q equals 200, and the supply function for it is given by that, compare the quantity demanded and the quantity supplied when the price is $60. So the quantity demanded, that is going to be our demand equation, which is right here. And we're going to say 2 times when the price is 60, so P is price, Q is quantity. So when the price is 60, how many pairs of shoes are demanded? How many people will buy them? And so then subtracting that 120 over, I would get 5Q equals 80. And then dividing out the 5, I get Q equals 16. So 16 units are demanded when the price is $60. How many are they willing to make is the supply. So that's the second equation. And so if the price is 60, how many of these things are they willing to produce? So subtract the 60 over, negative 2Q equals negative 50, and then Q equals 25. So at $60 a pair, they're willing to produce 25 pair. So will there be a surplus or a shortage or a shortfall at this price? So surplus means we'd have extra shoes. Shortfall means that not as many people got shoes as wanted to buy the shoes. And so there will be a surplus because the quantity supplied was 25, so they were willing to make 25 pair at this price, but only 16 people were willing to buy them, so there would be extra shoes. Okay, number 7. So suppose a certain outlet chain selling appliances has found that one brand of stereo system, the monthly demand is $240 when the price is $900. However, when the price is $850, the monthly demand is $315. So assuming that the demand function is linear, write the equation for the demand using P as price, Q as quantity. Okay, so here we have a quantity going with the price, and I'm going to write this as QP, just because that's generally the order they're given. So my first one is 240 goes with price of 900. So when the quantity is 240, the price is 900. And the second one is when the price is 850, then the demand is 315. And that's where you have to kind of stop and figure out what you're going to do here, is so that you're being consistent if they, do the wording backwards like they did here. So the quantity would be 315 if the price is 850, which makes sense. If the price is lower, more people would want to buy it. And so that's probably the hardest part, is just getting yourself organized from the words. So decide, which is your X, which is your Y. I like to write it out and then write those ordered pair and make sure you're getting them in the order that you defined here. So then M is 850 minus 900. Oops. And then 315 minus 240. And so I got negative 50 over 75, or negative 2/3. And then I'm just going to do that same equation again, P minus P1, M, and then Q is like our X, so Q minus Q1. And we'll toss in the slope and a point, and I did the first one. So P minus 900, and then our slope is negative 2/3, and then this would be Q minus 240. And I just clean that up, and then that's going to be my prices, a function of quantity. So running the negative 2/3 through, negative 2/3 of 240 comes out to positive 160. I'll add that 900 over, so P equals negative 2/3 Q plus 1060. So that would be our price and quantity. Okay, so for part A, we're labeling each function as either supply or demand. So let's kind of look at each of the functions and see what they're doing. For this first one, and again, the horizontal is quantity, and then the price is on the vertical axis. So right here, when the quantity is 0, the price is 10. When the quantity is 60, the price is like 40 something. So at a low price, the quantity is 0. At a high price, the quantity is more. So that's going to be a supply function, because when the price is low, they don't want to make that many of them because they're not making money. But when the price is high, they'll make as many as they can because they are making money. So this one is going to be supply. And then looking at this one, 0 when the price is 40, and then 66 when the price is like maybe 8-ish or so. So here we're not selling any of these when the price is high, and we're selling lots when the price is low. So that's going to be a demand. B, which of the labeled points is the equilibrium point? So that is going to be C. That's the spot where the quantity supplied and the price, where the supply and the demand are equal to each other. And then determine the price and quantity at which equilibrium occurs. So it looks like, it's a little hard to read on the graph, but it looks like the quantity is 30, and the price looks to be 25. So when we make 30 of these, we sell them for $25, and it's the same number that are supplied that are in demand. 9 is find the Marquardt equilibrium point for the following demand and supply equations. So market equilibrium back here was when the quantity of the commodity demanded is equal to quantity supplied. So basically what we're doing is we're just setting these two equations equal to each other and solving. Because the place where they cross, that's going to be where the equilibrium is. So since they both equal P, I can set them equal to each other and just do 8Q plus 2 equals negative 2Q plus 306. I'll bring the Q over and get 10Q. Oops. And add this, or sorry, subtract the 2 over and get 304. And then dividing out the 10, I'm going to get Q equals 30.4. Once I have that, I can plug it back in, and then P will equal 8 times 30.4 plus 2, and then P equals 245.2. And so for this one, the quantity would be 30.4 units, and the price would be 245.2.